All right, let's look at the homework 8, problem number 7. All right, so we want to sketch the graph of f of x equals quantity 6 minus 3x times e to the x. All right, so let's answer the first question. We're looking for the domain. All right, so this is not a fraction. There's no square root or anything like that. So this is defined for all real numbers. So B. All right, check the answer. All right, we got that. All right, next part. All right, so we want to find intercepts. So let's do that. All right, so in order to find x-intercept, so let's say x-intercept, what do we need to do? We need to set y equal to 0, right? So we're going to just set the function 6 minus 3x e to the x equals 0. All right, then you can see that exponential function is never 0. So this part, there's no hope, right? Right, but we can make this part equal to 0. All right, so we have so we have 6 minus 3x is equal to 0. All right, then we can just subtract 6 from both sides. So you have negative 3x is equal to negative 6. Then we can just simply divide through by negative 3. So we know that the x is equal to negative 6 divided by negative 3 is positive 2, right? And if you want to find a y-intercept, then you set the x equal to 0. So we set x equals to 0. So you have basically plug in, y is maybe y is equal to, so plug in x equals 0. So we just have to compute the x of 0. All right, so you have 6 minus 3 and plug in 0 there. All right, maybe I should put a square bracket there instead of parentheses so that we don't get confused. Then you have e to the 0. All right, so we know that e to the 0 is 1. So we have 6 minus 0 times 1. So it's going to be 6. All right, so we know that the x-intercept is 2 and the y-intercept is 6. All right, so let's find that. X-intercept is 2, y-intercept is 6. All right, so we have that. All right, let's check the answer. All right, we got that. All right, asymptotes. So do we have any asymptotes? All right, so this is a little tricky one, but let's see if we can find one. All right, so here, there is no vertical asymptote because it does not have the rational function form or the denominator. So, but it could have a horizontal asymptote. So, for example, if you take the limit of this function f of x as x approaches negative infinity, right? If it goes to positive infinity, e to the infinity is going to be infinity, and this is going to be negative infinity, so it's going to be a negative, really big number. So, but here, if x goes to negative infinity, so you have 6 limit of 6 minus 3x e to the x, right? Then as x approaches negative infinity. All right. Then as you can see, if you do it this way, maybe you can see it a little bit better. If you rewrite it as a limit as x approaches negative infinity, All right, so I'm going to keep 6 minus 3x on top, and I'm going to put e to the negative x on the bottom. All right, so I put the negative power and put it on the bottom, right, which is equivalent to multiply by e to the x. All right, then we can use the L'Hopital's rule, because as x approaches infinity, our numerator is going to be 6 negative 3 times negative infinity, so it's going to 6 plus infinity, so it goes to infinity. All right, as x approaches negative infinity, e to the negative negative infinity is e to the infinity, so this approach is also infinity. So when you have infinity over infinity, we know that we can apply L'Hopital's rule. All right, so if you do that, then you have a limit. All right, remember that you take the derivative of the top and the bottom separately, right? Take the derivative of the top, derivative of 6 is 0, derivative of negative 3x is negative 3, and the derivative of e to the negative x is e to the negative x multiplied by negative 1, so it's a negative e to the negative x. All right, then you can see that we can cancel, the negative sign on top and bottom, and then see where this guy goes. Right? We know that as x approaches negative infinity, e to the negative infinity approaches positive infinity. Right? 3 divided by a really big number is going to approach 0. Right? So which means that y equals 0 is its horizontal asymptote, but there's no vertical asymptote. Right? So here. All right, horizontal asymptote is y equals 0, and vertical asymptote none. All right, let's check the answer. All right, we got that. All right, summarize the pertinent information about the f prime. So here, we have to take the derivative. All right, so let's look at that. All right, first, since 3 and 6 have a 3 in common, so I'm going to factor 3 out of there. So you have a 2 minus x e to the x, right? Just easier when you take the derivative, so you simplify first. All right, then we take the derivative of f. So f prime of x is equal to, all right, so 3 is just a constant multiple, so you can put it outside. Then we can apply product rule. So here's the first guy, here's the second guy. So you take the derivative of the first guy, you get the negative 1 times the second e to the x, plus first guy is 2 minus x, and the derivative of the second is still e to the x. All right, so that's the product rule. All right, then you simplify as much as possible. So you can see that this is going to be 3 is going to stay there. All right, so it's a 2 minus 1, so it's going to be 1. And there's a negative x, and then both of guys have e to the x. So we have that. All right, then we can just set that equal to 0 to find the critical number. All right. Like before, we know that here, e to the x is never 0. And of course, 3 is never 0. But we can make 1 minus x equal to 0, which means that x is going to be 1, right? So x equals 1, right? So we can do a number line. So you draw a number line, all right? And the critical number is 1. So I'm going to put a 1 here. All right, then look at the sign. So you have f prime. You can do anything less than 1. So I'm going to try a sample number, x equals 0. All right, then plug in 0 into the derivative, see if you get a positive or negative, right? E to the x is always positive. 3 is always positive, so I'll probably just put the positive sign here and positive sign there. If you plug in 0, 1 minus 0 is still positive, so everyone's positive. right? And if you go beyond 1, so we can try a sample number x equals 2. All right, then here's the difference. 3 is positive, e to the x is always e to the 2 is positive, but the 1 minus x is going to be negative. All right, so it's going to be positive times positive is going to be negative. All right, so we know that the original function f is going to be, right, positive derivative, you have increasing graph, negative derivative, then you have a decreasing graph, right? So before 1 it's increasing, after 1 decreasing, right? So let's see if we can do that. Okay, so it's before 1 it's decreasing, but we want it to be increasing, so D is the right answer, right? Decreasing after 1. All right, let's check the answer. All right, we got that. All right, then you want to find the local max or local min. So if you look at this, all right, you have basically increasing picture in the beginning, and after 1, it's a decreasing picture, all right? So you can see that at 1, you're looking at the top of the hill, so you're going to have a local maximum, right? So let's check that. So there's a local maximum at 1. So A is the correct answer. All right, let's check the answer. All right, we got that. All right, and then we have to take another derivative. So let's do that. All right, so we have f double prime of x. All right, so 3 is just a number, so put that there. Product rule. All right, so this is the first guy, this is the second guy. All right, derivative of the first is again -1 times the second, e to the x, plus first guy is quantity 1 minus x. Derivative of e to the x is e to the x. All right, so if you clean it up, you have a 3, which is already there. All right, so you have a 1 minus 1, so they cancel out. So you can cancel these guys out. But you still have a negative x. So you have minus negative x. Then you still have e to the x. All right, so this is actually negative 3x e to the x. All right, so if you set that equal to 0, you can see that, x equals 0, right? X equals 0. All right, then we can do a number line again, but this time we're going to do it for the second derivative. So we have a number line here, and you have f double prime. Then you're going to put the 0 here. Then you can try anything less than 0, so I will try -1. After that, I'll try +1. All right. So you see that here, sign's easy to tell. So here, you have -3 is negative number, and you try -1, so that's going to be positive. E to the x is positive, so it's going to be positive. All right. Then after 0, you plug in 1. So -3 times 1 times e is going to be still negative. All right. So you can see that this tells you that the original function is going to be concave upward before 0 and concave downward after 0, right? So so we have that. All right, let's see if we can answer the next question. Let's see here. All right, so it was, I forgot which one it's concave up into concave down. So, all right, so you have a concave upward before 0, concave downward. So it's a C is the right answer. All right, we got that. All right, anything else? Inflection point. All right, so inflection point is of where concavity changes. So you can see that here at x equals 0, concavity changes from concave up to concave down. So we know that there's going to be an inflection point at 0. All right, so let's inflection point at 0. So C is the right answer. All right, we got that. All right, and what else? All right, so we need to pick the correct picture. All right, so we know that increasing turning into decreasing. Which one is that? All right, this one looks A looks okay. All right, B is eliminated. In the beginning, it's not increasing. All right, C is promising, and the D is you can eliminate that because it's starting out decreasing. All right, so this is going to be between A and C. All right, and we also know that the Y-intercept, right? What was the Y-intercept? The Y-intercept was 6, right? If you look at that, all right, so Y-intercept is below 5. It's like a 3 there on A, so A is eliminated. So we know that the C is the only one. Looks like it's going to go through 6 there. All right, so let's check the answer. All right, we got that. All right, that's it. I hope that this was clear.